You've learned about exponents and their properties in your previous math courses. In the previous Ready, Set, Go video, we reviewed both the product and quotient rules for simplifying exponential expressions. The product rule tells us that when we multiply two powers that have the same base, we can simply add the exponents together. The quotient rule tells us that when we divide two powers that have the same base, we can simply subtract the exponents. Let's review a few more exponential rules in order to prepare you for these ready questions. The power rule for exponents tells us that when a power has been raised to another power, you can combine the exponents by multiplying them together. We can see why this is true based on an example. The rules for rational exponents allows us to rewrite roots as fractional exponents. Here's an example. Here's another example. In the task you did today in class, Inverse Universe, you practiced matching functions and their inverses. You worked with functions in many different forms, including equations, graphs, tables, and verbal descriptions. In these set questions, you will continue working with functions and their inverses. As you write the inverse of each function, think about the properties and characteristics that you have discovered during this unit. The operations in the inverse function are the opposites of the operations in the original function, and they are performed in the reverse order. The graph of a function and its inverse are reflected across the line y equals x, as shown in the graph below. The domain of a function is the range of its inverse, and the range of a function is the domain of its inverse. The point AB on the original function corresponds with the point BA on the inverse function. In Math 1, you studied quadratic functions and how to factor their expressions. You learned that factoring an expression is basically undoing polynomial multiplication. Let's review factoring quadratic trinomials. Consider the following expression. If we want to factor it, we want to know what was originally multiplied to get this expression. If we use the area model to multiply, our polynomial would have been the area inside the box. We only have one linear term, but two spaces where there would have been a linear term. To find what the terms were before they were simplified, we need to consider some patterns. What are two numbers that you could multiply to give us a times c and add to give us b? Once you find these two numbers, you have all the area you need for your box. Now you can look for common factors on the rows and columns to figure out what must have been originally multiplied. Now we can write our linear factors as binomials.